Hello and welcome to today's lesson on friction practice problems. And today we're going to be looking specifically at friction on an inclined plane. So here's our practice question, our practice example. There is a 75 kilogram box sliding down a 25-degree ramp with an acceleration of 3.60 meters per second squared. We're looking to find the coefficient of kinetic friction between the box and the ramp. And that is step one. And then we'll answer step two, which is what would the acceleration of a 175 kilogram box have been on this ramp. So I have a 75 kilogram box, 25-degree ramp, acceleration is 3.60 meters per second squared. So let's get started. Step one, draw a picture. So my picture here has a box, 75 kilograms, 25-degree incline, and acceleration of 3.60 meters per second squared. Okay, so some things that I know, things that I need to know. One, obviously I know there's a mass of 75 kilograms. I know that my net acceleration, so A net, is 3.60 meters per second squared. I know my angle 25 degrees. So some things that are happening to go with this. One, gravity is pulling downward. Gravity is an acceleration, so I'm going to make my accelerations all in red. So I'm going to remake this arrow. I should just erase that. So I'm going to rewrite those. So all my accelerations are going to be in red, just to keep things kind of the same. So I have this at 3.60 meters per second squared. Gravity pulls down with an acceleration of 9.81 meters per second squared. So from this, we can do a couple things. One, I'm going to change this. So I'm going to make all my forces in the y plane blue and all my forces in the x-plane green, just so there's a distinction between them. You kind of see a difference. First thing, we need to change our axis. And so instead of having a normal x and y axis set up like so, we're going to rotate it. So it's going to run through here. So it runs parallel to my ramp. And so this is going to be y, this is going to be x. Okay, and I'm looking for, I should have put this down, ultimately I'm looking for mu k, my coefficient of kinetic friction. That's the end-all be-all goal. So that's what we're trying to get to. So we know that I have gravity pulling down at 9.81 meters per second squared. Instead of this, I can make this a force by using Newton's second law and having F equal to mass times acceleration. And if I do that, then I can erase this. I can make this blue because it's in the y plane. Well, I should leave this a different color because it's not in the y plane. This is gravity as a whole. And so we'll do this one in a different color than red. We're going to put the force. And so we have gravity going. Here's my yellow line. Let's see, green, blue. Let's make gravity, we should have left gravity red, but we're going to make gravity a force. So if I take 9.81 times 75 kilograms, my gravitational force is going to be 736 newtons. So this is 736 newtons. So down here I can write in white, so it's separate and the same. F of G equals 736 newtons. Now because this is pulling vertically here and not directly in line with the ramp and not directly perpendicular, we need to have components. And this is where we can get an x and a y component. Now, because this is 25 degrees, where the gravity bisects your horizontal axis here, this would be 90. So if this is a 90-degree angle here, and this is 25, I know that 90 plus 25 plus whatever this is, we'll call this theta, has to be equal to 180. So 90 plus 25 is 115, plus 65 gets us to 180. So this angle here then is equal to 65 degrees, and we're going to use that. So this is 65 degrees because now my gravity is going to have an x and a y component to it. And so with this, I'm going to make gravity perpendicular to I'm going to make my triangle perpendicular to my ramp here. So here's my ramp. I'm going to erase this because it's going to make things complicated and confusing. But that's still 25 degrees. But now I have gravity going this way. So there's my 90-degree angle. I guess I could rewrite this 25 here. And I have a horizontal component which goes from this point to here. So I have an f in the x direction, f sub x, and I have an f sub y. And I can find my f sub x using my trig functions. So I know that the cosine of 65 degrees is equal to my adjacent, which is my x value. It's going to be x over my hypotenuse, which is 736 newtons. So to solve for x, I would multiply 736 times cosine of 65 degrees. When I do that, I'm going to get a value of 311 newtons in the x direction. So my f sub x over here is 311 newtons. Okay? My force in the y direction, because I used cosine here, I'm going to use sine this time. So I'm going to take the sine of 65 is equal to my f sub y over, again, my hypotenuse, which is 736 newtons. Multiply this across, my f sub y is going to be equal to 667 newtons. And so because of that, now that I have gravity split into its components, because this is going into the ramp here, I know that my normal force going the other way has to be equal and opposite. So this is also going to be 667 newtons. This is my F sub n. So down here I have my normal force, which is F sub n equals 667 newtons. Now, I have all of this. I know that I have 311 newtons going in the x direction, in the x plane here. So I should have a force of 311 newtons this way. But I have a net acceleration of 3.60 meters per second squared. So if I would take 75 kilograms, I can calculate my force is equal to 75 kilograms times my net acceleration of 3.60 meters per second squared. My net force is going to be equal to sorry, 1 second. My net force, if I take 75 times 3.60, I'm going to get a value of 270 newtons down this plane. So I get 270 here. Well, that's a problem, because I only have, I have 311 from gravity, but I have a net force of 270. That means if I take my net force has to be equal to all my forces added together. So this is equal to the F of G in the x direction plus your force due to friction. So I know that 270 has to be equal to 311 plus whatever this force due to friction is. So I can subtract 311 across, and I'm going to get a force of friction equal to, I'm going to call it a negative 41 newtons here, but negative just means in the opposite direction. So my force due to friction, we'll put this over here, is equal to 41 newtons. So now I have a normal force here, let's use yellow, a normal force here, and I have a force due to friction here. My coefficient of friction my coefficient of friction is going to be equal to my frictional force over my normal force. And so I can calculate my coefficient of friction by taking my frictional force of 41 newtons and dividing it by my normal force of 667 newtons. And if I divide those two, 41 divided by 667, I should get an answer of 0.0615. So mu k was 0.0615. That is my coefficient of kinetic friction. Okay, so we know that now, and that's our answer to the first question. Okay, I have a question for you to solve here, which is number 5. So this is the same exact setup. A bundle of bricks is pulled up the ramp to a construction site. The bundle has a mass of 510 kilograms. The incline is 14 degrees. If the minimum force needed to move the bricks is 4,100 newtons, what is the coefficient of static friction? So instead of kinetic, we're doing static between the bricks and the ramp. This 4,100 is going to be the force needed to just barely overcome static friction, so we can say that is equal to your value there. And then if you get done with that and would like to backtrack, the second part of this question had what would the acceleration of a 175 kilogram box have on this ramp. So you can do this same question with 175 kilograms instead of just 75 and see what you get for the acceleration here. But that is today's lesson. Thank you for your time and attention. I wish you the best of luck. If you have questions, please let me know. Otherwise, I will see you next time.